In this video, we're going to look at section 6-3, dividing polynomials, part 2, but today we're going to focus on remainders, because when we divide, there's a chance we might have remainders. So, I'm still going to start my problems the exact same way. 6x squared minus 4x plus 2 divided by 3x plus 1. So here, again, I want to ask myself, what's 6x squared divided by 3x? And that leaves me with 2x. Okay, so again, I'm going to distribute. I get 6x squared minus 2x. I'm going to subtract these, plus 2x, sorry about that. And then, so we cancel out here. And then negative 4x minus positive 2x, which leaves with negative 6x. Bring down my 2. Okay, so now I get, again, how many times is, what is negative 6x divided by 3x? And I get minus 2 when I divide the 2. So I'm going to distribute, I get negative 6x. And then 1 times negative 2 would give me negative 2. So I'm going to subtract. Now this is where a lot of people might get stuck up. When I subtract, these cancel, but 2 minus negative 2 is actually 4. Now, we don't want variables on the bottom, so we can't take 4x and divide by 3x, so we're done. Well, we're done dividing, but now we got to take that plus 4, and we got to divide it by our divisor, our 3x plus 1. So if you get to a point where you can't, where the power of the divisor is bigger than the number you subtract down to, you're done. That's your remainder, so you put it over the divisor. So we're going to look at doing that. So our final answer is 2x minus 2 plus 4 over 3x plus 1. So now we got a different type of situation. We have x cubed minus x squared plus 2x minus 1 divided by x squared plus 1. So again, nothing is different with how we start. X cubed minus x squared plus 2x minus 1 in the box, and then x squared plus 1 on the outside. So I still ask myself, look at the first ones. X cubed divided by x squared, that's just an x. So I want to put it above the x. So now when I distribute, I get x squared times x, which is x cubed, and then x times 1 is just x. So, I mean, so now I'm left with x cubed plus x, and I have this big blank space. So the x cubes cancel, but negative x squared minus nothing is negative x squared, and then 2x minus x would just be a positive x. So again, I'm going to ask myself the same question. How many times does x squared go into negative x squared? So that would be a minus 1, so I'm going to distribute. So I get negative x squared, and then minus 1. Oh, I forgot to bring down my other positive 1. My subtract 1, there we go. Makes more sense. Okay, so now again, I'm going to subtract. Cancels out, so, but I'm left with x, and then minus 1 minus a negative 1 would cancel out, so I'm left with x. Well, x squared can't go into x, so I'm left with plus x over x squared plus 1. And there we go. So my final answer is x minus 1 plus x divided by x squared plus 1. Okay, now last one. This one's a little bit different, so please pay attention. Now notice, I have x to the 4th minus x squared plus 5. I'm missing some things. So you need to make sure you do x to the 4th plus 0x cubed minus x squared plus 0x plus 5. Okay, we need to have those in there because it could throw everything off. And then add our regular x squared minus 2 on the outside. But again, my problem still stays the same. How many times is, what is x to the 4th divided by x squared? That's just x squared. Distribute, we get x to the 4th and then minus 2x squared. Subtract. So we have 0x. So this cancels out. That's fine. 0x. Well, that's still nothing. So it kind of works out in our favor. And then we end up with a positive x squared plus 0x plus 5. So in this example, the 0x's are working in our favor because of how it's set up. But sometimes it doesn't always work out like that. So we get plus 1. So distribute, we get x squared. And then again, no zeros. So like I said, the x cubes and the x zeros, 0x's don't affect us in this problem. Subtract. So we get just a positive 7 as our remainder. So we have plus 7 over x squared minus 2. Okay. So, like I said, in this case, the missing x cubes and the 0x's, they don't affect the problem much, but they can. So always make sure to bring those in just in case, because this is a rare situation where this will happen.